Hello, my name is Tommy, and I'm here with Chiri to present our case study on predicting bankruptcy using the data of bankruptcy year one. To provide a little bit more details of our data sample, it's composed of 120 observations, which means 120 different firms, and it has 24 different financial ratios of the corresponding firms in either manufacturing or retailing industries. And the data is retrieved from CompuStat tapes and Moody's Industrial Manual. And the data is collected from 1970 to 1982. Our first outcome variable is cash over current debt ratio. And our second outcome variable is a binomial variable, which indicates either a firm has gone bankrupt or not. We have selected a total of 10 different variables, 5 variables pertaining to Y1 variable, and the other 5 variables pertaining to Y2 variable. And the 10 variables are cash over debt, cash flow from operations over debts, current asset over current debt over total debt, sales over receivable, cost of goods sold over inventory, income over sales, income over debts, assets over debts, and finally, working capital from operations over debts. And with our partitioned our data into 60% training and 40% validation. So moving on to the explanatory analysis of Y1 variable, which is cash over current debt. This histogram shows the first frequency distributions of Y1 using the full sample. And we can see that most cash over current debt ratios lie below 1, meaning that the size of cash most firms are holding is actually less than the size of their current debt, although there is an outlier firm with cash over current debt close to 5. So to provide further information about our 5 selected variables, in terms of Y1, size of cash relative to its current debt averages around 0.28, and R4, cash to total debt, should intuitively be smaller than Y1, and also averages around about 0.50, and R7, cash flow from operations over debts, has a minimum of negative 0.61 and maximum of 1.16. And current asset over current debt ranges from 0.27 to 9.48. Debt over debt ranges from 0.14 to 1. And lastly, sales over receivable ranges from 0.76 to 138.71. And below is a chart that shows the correlation between Y1 and R4. And we can definitely observe a clear positive relationship between those two variables. So moving on to how the selected variables are correlated with Y1. Unsurprisingly, R4, cash over debt, is highly correlated with Y1, since current debt, the denominator of Y1, is essentially part of the total debt, which is also the denominator of R4. And in addition, under the similar logic, R9 is somewhat highly correlated with Y1 as well, since its numerator, current asset, also includes cash, which is the numerator of Y1. Other than those two variables, the other 3 variables show very weak signs of correlations. Moving on to our model 1 of regressing Y1 against 10 selected variables using the training data. We can observe that only half of the variables that are used are statistically significant at 5% significance level. And then we run accuracy predictions using validation data to find out that the corresponding RMSE of this regression is equal to 0.162, and its adjusted R squared is equal to 0.757. Then we're on a stepwise regression using the both method for Y1 against 10 selected variables using the training data. And we can see that the number of independent variables has been reduced to 6, with only one variable insignificant at 5% level. We then run accuracy predictions using the validation data to find out that the corresponding RMSE is equal to 0.166, and its adjusted R-square is 0.761. The stepwise regression now has less parameters than the original regression, which makes this regression more parsimonious, although there is a very slight increase in its RMSE.
Okay, hello everyone. My name is Chire and I'll continue for the second part of the presentation. So for the explanatory analysis of Y2, we use the full sample data, which is 120 observations. So Y2 is a binary dependent variable. In our case, it is denoted 0 when the bank failed and 1 when the bank is healthy. So from the table, we can see that there are 66 bankrupted firms in our sample, which is 55%, and we have 54 healthy firms, which is 45%. The numbers are quite even. And the bar plot here is just a better visualization. So for the box plot, we have Y2 and R15 here, which is income over debts. Just keep in mind that the data for failed firms are from 2 years before they went bankrupt. And we can clearly see that the ratios for the firms that are close to bankruptcy are much lower than healthy firms. The average income over debts is close to 0, and many have negative numbers for bankruptcy firms, which makes sense. And the income over debts for healthy firms are almost all positive, except for one outlier. So the next box plot is asset over debts. Again, same pattern here. Healthy firms generally have more assets over debts than firms that are close to bankruptcy. The mean for healthy firms is around 2, meaning their assets are 2 times of their debts. There's an outlier that has 14 times more assets than its debts, and it's very impressive. So for Model 3, we're using a logistic regression for Y2 against the 10 selected variables, and we're using training data. So here's the result from the regression. We can see that only 2 variables that are statistically significant and 5% level. They are R12, which is current debts over total debts, and R21, which is asset over debt. So apparently debt is the most contributing factor here when it comes to bankruptcy. So then we measured the accuracy of our predictions using validation data. Here's the confusion matrix. We can see that the diagonals are the correct predictions, 26 and 12, and the wrong ones are 8 and 2. So overall accuracy is about 80%, sensitivity about 93%, specificity is a bit low, only 60%. The area under the curve is 87.7%, which is not bad. For Model 4, we use a stepwise logistic regression model for Y2. We choose to use both forward and backward selection using training data. Out of the 10 variables, the model selected 4 variables, and it turns out to be all statistically significant on the 10% level now. And again, we use validation data for accuracy measures. Here's the confusion matrix again, and we see that 25 and 15 correct ones, and the overall accuracy is now 83%, which is slightly higher than Model 3. And sensitivity is now 90%, specificity is 75%. The area under the curve is now 0.864, sorry, which decreased about 1%. We can say that the area under the curve is still very close to Model 3, but Model 4 uses fewer regressors, and they're all statistically significant, so it is more parsimonious. Therefore, we can say that Model 4 is preferred. So in conclusion, we analyzed outcome Y1, cash over current debt, and concluded that the best prediction model is stepwise regression model. It uses 6 variables instead of 10, and the root mean square error stayed pretty much the same. For outcome variable y2, which is whether the firm goes bankrupt, the best prediction model is stepwise logistic regression model. It also uses fewer regressors, and they're all statistically significant without decreasing area under the curve too much. So that's it for our team. Thanks for listening.